Now we have simultaneous equations that are not linear, that are not straight lines. I have here a simultaneous equation, x minus y equals -1, and y equals x squared plus 1. Because of the x squared, this is not a linear. Now, what is this? The top equation is a straight line. The bottom equation is a parabola. But we're going to solve this. We're going to use substitution. I'm going to go into the first equation and solve for y. So from the first equation, I get y equals x plus 1. Then I'm going to take that. Then I'm going to look at the second equation. I'm going to take that x plus 1 and plug it into the y over here. So I get x plus 1 equals x squared plus 1. This gives me x squared equals x, which gives me x squared minus x equals 0. So x winds up equaling 0 or 1. Now I have to check, will these x values give me good y values? Well, let's start with x equals 0. For x equals 0, I plug in, I'm going to have to do it into both equations. You always have to do both equations. 0 minus y is 1, so I get y equals 1. Y equals 0 squared plus 1. Y equals 1. Again, I'm plugging in 0 for x in these two equations. So that gives me x. So if x is 0, I get a consistent answer of y equals 1. So 0, 1 is part of my solution set. Now I want to look at x equaling 1. So if x equals 1, again, I plug 1 in for x here, then I plug 1 in for x there, and we'll see. And I must, if I have to get the same y value each time, otherwise it doesn't count. 1 minus y equals -1, negative y equals -2, y equals 2. Y equals 1 squared plus 1, again, y equals 2. So this represents the point 1, 2. So there are two solutions, 0, 1, and 1, 2. Now, how is it that, what does that mean geometrically that there are two solutions? Well, it means as follows. If I graph these two guys, the top one is a line and the second one is a parabola, and the line and the parabola intersect at these 2 points, 0, 1 and 1, 2. That's exactly what it means. So I get it all in one picture so you can see the whole thing. Before I move on to the next problem, I want to just point out that when you have, if you recognize you have a line and a parabola, well, there's really like a bunch of possibilities. You could get two solutions like we got. You could just get one solution because the line just kind of nicks the parabola. It's tangent to the parabola. You could also get one solution this way. The line goes through the parabola, but it's the only place it hits the parabola. Or you might have no solutions because the line misses the parabola. So you could have two solutions, one solution, no solutions. These are all possibilities. The algebra will bear out which one it is. Now for our next problem, we have x squared plus y squared equals 5 and y equals 3x minus 5. Well, we recognize that that's a circle and that's a line. Now it's just a question of the circle could hit a line could hit a circle twice. A line could just be tangent to a circle, or a line could miss a circle. So there might be two answers, one answer, no answers. It's all geometrical. See, here's a line that hits the circle twice. Here's a line that hits the circle is tangent to the circle, and here's a line that missed the circle altogether. But again, the algebra will always bear it out. So let's do some algebra here. We're gonna take we have x squared plus y squared. X squared plus y squared equals 5. We're going to take the y here, the 3x minus 5, and we're going to put that right into there. So where was a y, now it's 3x minus 5. Now I just have to expand this, and I get x squared plus 9x squared plus 9x squared minus 30x plus 25 still equals 5. Bring the 5 over to the other side. I get this. Divide everything by 10. I get this. Factor. I get this. So I have x equal 1 or x equal 2. Now I have to see if these answers work out. It could be both of them will work out. It could be one will work out. Anything is possible. It could be that an answer, we'll see. But when x equals 1, I have to put it into both equations. So I put in the first equation is 1 squared plus y squared equals 5. And that gives me y equals plus or minus 2. If I put it into the second equation, I get y equals -2. So now, that means that the plus or minus 2, the minus 2 gets accepted because it matched with the second equation, but the plus 2 gets rejected. So the only solution I have is 1, -2. Sometimes the 1 will match. Sometimes you'll get plus or minus 2, plus or minus 2. Sometimes they'll both work, but here only one of them worked. When x equals 2, because in order to work, it has to work in both equations. When x equals 2, I plug it into the first equation, I get y equals plus or minus 1. I plug it into the second equation, and I get y equals 1 only, so I have to reject the -1 and just go with 2. The 2 comes from there, 1. What does this look like geometrically? Funny you should ask. It basically looks like a circle. We knew it was a circle in a straight line, and this is the circle. The line hits it at this point and at that point. Those are my two solutions, and everything is hunky-dory. Here we have a x squared plus 2y squared equals 10, which we recognize as an ellipse, and x squared minus 2y squared equals negative 2, which we recognize as a hyperbola. I kind of started the problem already. I jumped the gun here. But I'm going to add the two equations. I'm going to try to eliminate, and I'm going to add them up, and the y squares are going to cancel, and that's going to leave me with 2x squared equals 8, which means x squared equals 4, so x could be plus or minus 2. And again, we're going to have to try them both out. Well, if x is plus 2, again, I have to do the top and bottom equation and the bottom equation. I got to do both. I'm going to plug in x equals positive 2, so I get 2 squared plus 2y squared equals 10. That gives me y squared equals 3, y equals plus or minus rad 3. And now I do the second equation. I put 2 squared minus 2y squared equals negative 2, and that gives me negative 2y squared equals negative 6, y squared equals 3, y equals plus or minus 3. They both work. Since they both work, they both work in both equations, so I'm going to make them both as answers, 2 comma rad 3, 2 comma negative rad 3. Let's see what happens when x equals, let's look at the other solution when x equals negative 2. Let's see if that works. That was x equals positive, so let's try x equals negative 2. Well, if you notice, when x equals negative 2, I'm going to kind of get the exact same thing, because negative 2 squared and positive 2 squared is the same thing. So it's all going to work out exactly the same. Here's all the steps. And that gives me two more answers, negative 2 comma rad 3, negative 2 comma negative rad 3. So I have 4 answers to this system of simultaneous equations. So what could that possibly look like? Funny you should ask. It looks like this. I have my ellipse, and up here and down there is my hyperbola, and it intersects at those points. Now, for extra credit, you can figure out how I knew that was rad 5 and how I knew that was rad 10, how I knew that was plus 1, how I knew that was minus 1. You can figure that out on your own. But I have 4 solutions, and that's the geometrical interpretation of my 4 solutions. I just want to point out again that if you have a situation of an ellipse and a hyperbola, well, a lot of possibilities. You could have one solution because it's just the tangent, 2 solutions because they're tangent in 2 places, no solution because the ellipse misses the hyperbola. Here's 3 solutions because it's tangent up here, but it hits it at 2 places down there. Here you have 2 solutions because it hits this one twice and misses the top. Here you have no solution because it misses it because it's inside. There are numerous possibilities. I guess 0, 1, or 2 solutions, and there are different ways that it could play out. Anyway, this is my situation, beautiful situation, and that is that.